modulates the voltage and amperage to optimize. I came over to the Arlington Career Center and I gave a presentation on solar, and the thought crossed my mind that it would be great if some of these students that were interested in solar could participate in the actual installation of a system so that they could get some hands-on experience, and it was much more effective learning when I actually built something. So here we are.
You spent some time up there?
Yeah, a little bit nervous, but I feel a little bit better now. I got this one, so I'm good.
These two right here?
Those two, no, these are gonna go to the next TIGO. Let's go this way.
Climate change is a very, very real concern. One of the best strategies that we have at this time is implementing renewable technologies and reducing our carbon burden in producing energy. One of the most successful strategies is using photovoltaic panels.
Okay. When it detects a change in the voltage because there's shading, it makes an electrical adjustment so that the other panels are not affected.
Okay.
All right.
We are applying how to convert DC energy to AC energy. That was the practice that we did in electricity class, and that was great because now we are in the reality on the lands, and we are applying all the knowledge.
It takes what the students learned in the classroom, the core concepts, math, science, environmental science, and it allows students to apply those in a real-world setting. And so it's proven that when students have a learning experience, they're able to hold on and retain the information more, and they can comprehend it.
We're now up on the roof installing the panels. These are hybrid panels that combine both PV and thermal sun drum panels on the back side of the sun power panels. You get the double effect. You get electricity being generated out of the photovoltaic sun power panel, and then you get heat energy coming off the back side of the sun power panel, going down to heat the domestic hot water, heat the swimming pool, or heat the house. In the summer months, when you're taking heat out of the house, as we put it in the swimming pool, we cool the pool at night by rejecting the waste heat to the night sky. This particular design here is a relatively low temperature thermal using a heat pump technology. This represents the trace of the weather station over time. So you can see the wind speed oscillating as we go through time, and then also the solar collector temperatures and the air temperature are also being traced. On this next screen you can see natural gas being burned overnight to heat the house, and the amount of electricity that was being used to power the house. You can also see then the solar radiation as the sun came up at 7 o'clock. You can see that it's been cloudy ever since about 10:30. The blue line is the photovoltaic power generated, and the orange line is the thermal energy being generated from the heat pump.
Renewable energy is really important because we can save the environment for us, and we can use the sun which transfer that energy.
The students that came to work on this system, they'll be able to go to work for any other solar company, and it's great. That's really what the whole goal was to give these boys some experience, some hands-on learning, something they could put on their resume, that they've actually installed solar photovoltaic and thermal panels. This is pretty slick.
Mr. Nunez, we want to give you this certification for appreciation. You gave the opportunity. We work in the field. We practice our skill. So thank you so much.
Thank you very, very much. I appreciate it.
Thank you.
Thank you. Thank you both.